All right, so on this one, so we're going over the homework here. You said 21, 22, 23. Which one do you want to do first? Just do 21? All right, so when you're working on number 21, it says directions. Show that f and g are inverse functions algebraically using a graphing utility to graph f and g in the same viewing window. Describe your relationship between the graphs. So basically we're going to be doing like the very end of our notes yesterday, where we sit there and say, can I put one in for the other, and does it come out to be equal to x? If it is, we know then that they're inverses of each other, and then just double check it that we get the visual from it as well. So like on number 21, here is our f of x. It's going to be the square root of x minus 4. And our g of x is going to be x squared plus 4. But notice they gave a limit right here. Said x is greater than or equal to 0. Why would they give a limit to that? Yeah, because we have x is squared, and we'd have a parabola that has two sides. How many sides does the square root have? It only has one. And remember, I have to match it. So they have to limit it in order for that to happen. But let's do a quick first check. So I got f of g of x. So we got to plug it in. So that means I'm really going f of, and I'm putting in x squared plus 4. Wherever x is in my function. So when we do that, we get the square root of the quantity, x squared plus 4 minus 4. And then it's just simplifying it down. Guys, x squared plus 4 minus 4, what does that give us? X squared, right? Square root of x squared? X. So when we're working with that, pretty quick and easy to see. But now let's make sure the same thing happens when I go the other way. If I go g of f of x, it has to work both directions. So we need to check both. So when we do that, this time I'm looking and plugging in for my x and my g function, my whole function for f of x. So that's going to be g of the square root of x minus 4. Remember, it's just the substitution with substitution in again. All right, so let's keep on going with this then. So I'm going to put in for my x squared the square root of x minus 4 squared plus 4. Well, here's the math. It's nice. If I square a square root, what comes out? The answer was underneath, right? So we get x minus 4 plus 4. Well, isn't that x? So did it come out where my composite functions both equaled x? All right, so now we have to do the quick graphical on here, see if I can get this to come up without it messing up my whole screen here. But now you just have to do the quick graph of that. So pulling out your smart view calculator, go to y equals x here real quick. I'm going to clear my screen here, my functions. And you just put in your two functions that we have. So f of x, we're going to let that be the blue one, y1. And so that was originally on 21, the square root of x minus 4. All right. And then we're going to have, for g of x, it's going to be x squared plus 4, but it has to be x is greater than or equal to 0. Now, here's a problem with this. You have to know how to do piecewise functions a little bit. I'm going to show you. I'm going to see if this works. I could totally mess up because I'm doing this for the first time. Totally cold turkey. But go alpha y equals real quick and do number 1. Put in your x squared plus 4. All right, and then we're going to limit. We're going to put in our parameter for that function. That's going to be your g of x. All right, so with my g of x for this one, you need to use parentheses or this won't work. All right, and then you put it in exactly what you have here. Put a parenthesis in, and then remember, we have to go x. Okay, I got to remember where my greater than or less than equal to signs. I'm going to have to go to numbers. This is where I did not remember off the top of mine. No. You guys remember where our greater than or equal to signs are? This is where I do not remember on here. This is when I have to remember my, don't think it's, is it second math? Perfect. All right, second quit here. All right, go to y equals again, go back down here. Perfect. Thank you. You can tell that I've done so many piecewise functions on here. All right, so it'd be second math. Thank you. Big bucks need to be paid. All right, thank you. All right, so we have x is greater than or equal to 0, so I need to go pick number 4. All right, I'm going to do my inserts here to make sure that works. We're going to go x to make sure I go in front of it. Insert, second insert, parenthesis. All right, I'm starting to feel like I might actually get to work. This is good. All right, now I'm leaving my line y equals 3 in there. Guys, you can take that off, but why do I leave the line y equals x in there? Excuse me, y equals x. I want to see if it reflects, right? So that's the cool thing on there. All right, so let's just go ahead and let's go zoom 6, just go quick fix on there. It goes, so 6 is standard. Does it look like a basic reflection over it? So that's what you'd want to show on your your homework. So what would I show on the homework to prove that's the case? They both are at 4, correct? I'm going to minimize that. And on there, you should have just literally gone like, here's at 4, I'm going this way. And then I'm over here at 4, and I'm going this way. That lets me know that you had, and you're supposed to describe it, well, is it a reflection over the line y equals x? It's just the visual, the graphical display of telling me if they're going to be inverses or not. Does that kind of make sense on that one a little bit more, Owen? All right, should we try at least one more? Will that be good? Guys, which one do you want to do? Cubic or, let's do 23 because that's a cubic. Are you guys good with doing a cubic real quick? All right, so let's do a cubic. Let's do 23. All right, on 23, our function this time is we have f of x equals, okay, this is just, I'm going to ask this. Guys, what's your parent function for that? This is written weird, so I'm just curious again. What is it? X cubed, so it's a cubic, okay. Do I have a reflection? Do I reflect over the x or y axis?
X.
X because it's front of the x squared. Okay, great. Then, do I have a horizontal shift? Yes or no?
No.
No. Do I have a vertical shift? Of 1. So basically, you could rewrite it and get everything needed from there. Not that you need to in this case, but you should be able to look at that and still pull out the needed information from there. All right. Then we also have our g of x this time is the cubic root of 1 minus x. And notice you don't have as many limitations when you work with cubics because you can have negative answers with these and stuff, and it works out really well. But do the same thing. Algebraically show. Now, here's the thing. I could easily ask this on a test. It'll be like, verify or show me that these two are inverses. To me, the fastest way is algebraically. Could you do it graphically? You could. You just have to draw the graph and then explain from there. And then it reflects over the reflections over the line y equals x. So I'm good either way because you really don't need to do all 3. Like today we're going to practice all 3 in our notes. But you only need to show 1 overall and explain yourself. So verifying this, it's easy for us to do. We're going to go f of g of x. We want it to equal to x. So that means I'm plugging in for g of x. We're doing the cubic root of 1 minus x. That has to go in my function f. So what are we plugging here? We got 1 minus the quantity cubic root of 1 minus x cubed. Oh, love inverse operations, right? I'm cubing a cubic. What comes out is underneath my radical sign there. So I got 1 minus the quantity. And notice there has to be a quantity right here. Right? I don't want to mess up losing my negative sign like I need to. And that becomes 1 minus 1 plus x. Doesn't that just become equal to x? Make sense? Does everyone understand why I had to have a parenthesis stay there? All because of this thing called a subtraction sign. Remember, I'm subtracting that whole quantity that you're working with. All right, so it's easy to see. Great. This looks like our trend's going the right way on this one. But then we're going to go g of f of x. Well, my function this time is I'm plugging in the function f, so I get 1 minus x cubed. That goes into my function g. And then when we do that, we get 1 minus the quantity, 1 minus x cubed. So I end up getting 1 minus 1 plus x cubed. Oops, I forgot my cubic here. I get the cubic root of x cubed. Is that also x? All right, great. Now let's do it graphically real quick, and we'll just do it on our graphing calculator again this time. Nice thing that we don't have to put a limit on it this time. So doing this one, going back to our y equals, I'm going to clear these two. And then just plug in our two functions that were there on 23. So we have 1 minus the cubic root, cubed, excuse me, not cubic root. So we sit there and go 3. All right, do you guys remember how to put cubic root on your calculator? All right, you just got to go math, right? Go to your math key. And when you do that, it's number 4. And then you just have on this one, it's just going to be 1 minus x. So 1 minus x. All right, graph again. All right, what's cool this time, it looks a little funky, but they both end up crossing at what point? 1, 1. All right, so they both cross at 1, 1. Excellent when you're doing that. And you could literally see the reflection of the two on the graph. And you can see how it would just go right over the line, y equals x. Does that help just a little bit? So let's plug it in. So this is what you'd have to show for your graph. Make sure I can do this one. Doesn't want to click back on here. So let's go through. So on our graph, this would be our function f. Let me make sure I go over here. So it should have been like this. And then our function g should be coming down. If I can. Basic graph on there. No, it's real drawn to scale. Perfection. I just want to see what your graphing calculator did. Does that make sense? All right, Owen, does that help on those? Yes. Okay, awesome. Because we're actually going to practice that more later. Any other questions on homework? I'll throw back stuff if I remember as I go, like, oh yeah, don't forget this for the test type thing as we go. Sound good? All right, so grab your notes, my friends. We are going to sit there and we are going to practice exactly what we just were doing, okay? We got to practice verifying inverses. This is a huge calculus route for some of you who are taking calculus next year. You just have to be able to think algebraically, graphically, and numerically. The one that we haven't talked about is numerically when we're working with it. So keep your calculators because we're going to let that be our quick cheat just so we don't have to sit there and graph everything real quickly ourselves when we're doing it. So right away, I am doing, I think this is, I have a typo in mind. I think we did 29 on here, and I did 26, 28, and 29 from page 148 in your textbook. Notice the ones I suggest if you want to try some more, 25, 27, and 31 would be if you want to practice these on your own, because some of you are phenomenal at wanting to get prepared for tests. Some of you avoid it, but it still doesn't mean something like that's not going to be on the test, okay? Hint, hint. At least probably just one question, but you know what I'm talking about. Make sure you know how to do these. So this is review, but the one thing we hadn't talked about was the numerical, and so that's what we're adding on. So making sure we have this. So the thing is, it's just verify algebraically, graphically, and numerically. So we're doing the trifecta. The nice thing is, if you ever have to verify that the functions, two functions are inverses or not, you really only have to do one of the three. But you have to be good at it, so you have to make sure it actually works with it. So let's do the first one. So this is going to be just like what we had on your homework type problem, is I have to, algebraically, that's when we plug and chug the functions into each other. So the very first are actually pretty easy. So I'm just going f of g of x. And so that really means I'm just plugging in a 4x plus 9 into my function f. So when you plug it in, here's the thing when you plug and chug stuff in, and this is something I need to emphasize because this happened on your last test, especially when you guys were doing your difference quotient. If you don't use parentheses, you lose track of negative signs or problems like that. So please make sure when you plug in things for the value, you put it in. Even if you know it doesn't make or break you, it does make a difference if you understand it or not. So when I plug this in, I get 4x plus 9, that quantity minus 9 all over 4. So when I simplify the numerator, I get a 4x over 4, and you get an x. And remember, the whole point is I want my composite functions to come out equaling to x. Then do the exact same process, which most of you are already probably working ahead on, and do the same thing, just the opposite composite function, where I'm putting the function f into function g. And this is just verifying that one's the inverse of the other. So with that, what do we get here? In the function g, we're going to put in x minus 9 all over 4. So we're going to get 4 times the quantity, x minus 9 all over 4, plus 9. Well, what happens to our 4s, scholars? Cancel out. Perfect. So I get x minus 9 plus 9 equals what? Equals x. Awesome. Excellent. Lane, I need you to stay with me. All right. Heads up. You can still watch. I know, but you can still watch. Pay attention. Hey, guys, and I see some cell phones on your desk. I'm thankful you're not using them, but where are they supposed to be? Can you please put them in your backpacks? I appreciate that. Keeps temptation away. And honestly, I appreciate you weren't on them. I'm just asking you to put them away. You guys know the routine by now. All right, guys, graphically, we're good. We have the fact that they are both going to be equal x. Wonderful. They are algebraically, yes, they're inverses of each other. But on this one, it says graph both of your functions you're calculating. Now, this is a little bit harder to see. These are lines. Could you probably graph these pretty quick on your own? You could. If you want to just put really quickly what's on the calculator on here. But the part of the problem is the own is your intercepts and stuff. It's like nasty looking. But let's just go ahead and put it on your calculator. Go to your y equals and put your two functions in. The y1 is going to be function x. y2 is going to be our function g. So we're just plugging those two in. We're going to clear these. All right, can you tell that I want you guys to be on top of using your calculators? This is going to be starting to be really critical on future problems, so we're going to need to do this. Our whole next unit is calculator skills that we have to have. So bringing those back up again. All right, just plugging them in. Make sure you plug in your values. You should have your x minus 9 all over 4. Next one would be 4x plus 9, I do believe. And then, again, if you don't want to, you do not have to put in your y equals x. So I'm just going to make my point, I'm going to shut it off, and I'm only going to graph the two that I have. Can you give me at least a rough version of this on the page, right? So looking at these, they should be fairly rough. But like here, make sure this comes back here. You're going to have all the way up here is 9's your intercept, and you're going to be coming down. And then you should going to have another one that should be coming. I got to make sure I got this right because it's not going to look good when I'm doing it. The other one coming this way. It's not reflecting very well, but good enough. If you look at the calculator, it's much prettier than what I just drew freehand. Is it reflecting over the line y equals x? Is one reflecting onto the other? Like I said, I didn't draw it well. But looking at your calculator, are they perfectly going across that 1, 1? Here, plug it in if you need to. Go highlight that, enter, graph. Is it reflecting over it? It's a lot easier to see, isn't it, with the line y equals x? It's very easy to see that the blue line reflects onto the red, and the red reflects onto the blue over the line y equals x. So guys, do we have a reflection over the line? So when you're sitting there and you're verifying this, you can sit there and say they are inverses, and some reason we are erasing everything that I'm doing. All right, inverse functions. Because they reflect onto each other over the line y equals x. Basic on there. So I have reflections over that. Pretty easy to do. All right. Now, with this one, we've got to be able to work with it. We need to be able to also do this, what's called numerically. Like, I need to prove numbers. Now, remember yesterday, I literally think I said it once. Literally once. That says, if you have a point in one function, it has to be flipped in the other one. So let's just say, and this isn't true, I'm not plugging this in right here. Let's just say if I had a point in function f, some weird function f, if I said, okay, I got the value 5, negative 7. That means if they're inverse functions of one another, g of x is not going to have the point 5, negative 7. G of x is going to have the point negative 7, 5. So I need to be able to compare ordered pairs. What's the best way of comparing ordered pairs? Going back to those good old Algebra 1 days of making the charts. You make a chart for each function. But guys, you're strategic with how you do the chart. Okay? So like for instance, on the first one here, I want to make a chart for f of x. Actually, which one do you want to do? Do you want to do g of x first because it's the easier one to work with? Should we just do g of x first because it's easier? All right, so let's go with g of x. Let's do that one in blue to make our lives easier. So really it's x, and what comes out is g of x. Really in our brains, what comes out is y, correct? But really that's what we're working on. Remember, g of x is 4x plus 9. So I'm going to pick just normal numbers that you'd use that makes life easy. How about negative 2, negative 1, 0, 1, and 2? Now, what do I have to do? Good old-fashioned, before you learned how to use slope-intercept form and graph lines and that type of stuff, wouldn't I just plug it into the function? So really, wouldn't I go 4 times a negative 2 plus 9? Well, what was 4 times negative 2 plus 9? So I get 1. And then I do the same type of scenario, and I just do it with my other 4 points. So I just go put a negative 1 in. Well, 4 times a negative 1 is negative 4 plus 9. Well, that will give us 5. Always use 0 if you can. If it's not on it, that's sad. But if you got 0, I'm going to get 9. Plug 1 in. So 4 times 1 is 4 plus 9. I get 13. Go 4 times 2, which is 8, plus 9 is 17. So very easy to do. Now, strategically, remember the whole idea of this is I want them to flip-flop, right? Where the x and y locations are. How can I show that this is true? When someone says you switch it around. When you're doing your x's for your f of x table, what numbers am I going to try? Yep, you're going to want to go 1, 5, 9, 13, and 17. You want to be strategic to use those numbers when you plug them in. Because if you strategically use those, and I've done this right, and they're inverses of each other, I will get the other value. So this time, we're going to plug it into this function, okay? So we're doing that one over here. So if I'm plugging 1 in for x, I get 1 minus 9 all over 4. Guys, 1 minus 9 is negative 8. Negative 8 divided by 4, negative 2. And then do the same thing for the other ones. 5 minus 9, that's negative 4. Negative 4 divided by 4, negative 1. And notice you can do a lot of those in your head. I pick numbers that normally can go quickly in our head, too, when I'm doing this. Now, doing the same thing here, we can go 9. 9 minus 9 is 0. 0 divided by 4 is 0. Put 13 in. 13 minus 9 is 4. 4 divided by 4 is 1. Yeah, remember, except for what happens if it's inverse, the x and y's have to what? Flip. Remember when we were learning to write the inverse with this? What do? We switch the x and y's and then solved. Strategically, we're making this happen when we're writing an inverse for a function. Now, visually, are my points flip-flopping like they're supposed to? So isn't it inverse? Does that make sense?
How many do we have to prove?
I mean, you only have to do one of the 3 methods if you do it. And then we're only going to, I think, have 1 on the test. So it's not going to be that hard to do. You just have to show, like, is this an inverse or not?
Well, I mean, like, this specific one, like, if we proved the first 3, do we have to do the last 2?
I just picked 5. I just picked 5 to do. You normally go, like, between 3 to 4, probably. You just need to make sure that they flip. Obviously, we know it should have already been, we shouldn't have to do very many because didn't we already show it 2 other times? That's going to happen. Does that make sense with those? Okay, so here's what I want you guys. This one is not as much fun, but it will work doing this. Let's do 28. And then if you feel like we need to do number 29, we'll do it together. Sound good? because I mean, it's in your filled-in notes, but I don't want to take your whole time if you don't need it, but I just feel like it's a valid way of doing these. So, guys, how about you guys start doing this? I'm not going to say much. I'm just going to walk it through. I want you guys to do the algebraic step first. So you go ahead and do the algebraic step. I'm just going to pause it, and then we can check answers. Algebraically, this is what it should look like if you did it right. So algebraically, you should be right on. Graphing it, again, you should have cubics that we're working with. Now, that's an x cubed over 2. Doesn't that make that a wider, broaden it out, stretches it out just a little bit? It doesn't go as steep as quickly. So if you're doing that on your graphing calculator real quickly, go back to your y equals. I'm going to clear both of those and just plug them in. The nice thing is your graphing calculator is a nice check, and the reason why we're doing it on the graphing calculator right now is just to save time, just to make sure that we're all on the same page. But with this one, I would go x cubed. What do you got here? X cubed. Clear that though. Don't do what I just did on my calculator. Okay. All right. Much better to restart. All right. So we have x cubed. Now I feel better. All over 2. That should be spreading out just a little bit. Then our y squared is going to be our g of x, and that's going to be our cubic root. Remember math. Number 4. Plug it in here. What do we got? 2x. All right. Graph it. All right. I don't like how this looked. Now, this is something we're going to talk about in our next unit, but this is one of those things where I get so excited when Mr. Smith showed me something new. He talked to me about how to make a zoom box, which is so much fun. So you can actually zoom in what you want to see, which would be about here. Hit enter. And then I'm going to zoom over. See if it'll go down now. Here we go. Oh, didn't do it. I didn't hit enter right where I was supposed to. Zoom. This is when I have way too much fun learning new stuff, and you guys are the suckers who get to see it. All right, so zoom box. Did you guys ever learn this last year, the zoom box? All right, so the cool thing about the zoom box, it lets you look at only what you want to look at on the screen. Because remember, you could do the zoom in, and it totally, like, it doesn't want to go here. It's taking forever. All right. And you sit there and you have to like change the parameters. You just go zoom in, enter, enter, enter. Like it just goes crazy. Well, this allows us to sit there and go across here if it's going to let me do it. All right, across, and then I'm going to go down. And I literally make a box. It's going to let me start. This is why I wish I could just project my regular calculator to you guys. It's a little bit faster. But look how cool this is. It enlarges just where I told it to. Isn't that cool? Okay, I'm sorry. Technology is never cool sometimes. It just allows you to go in real quick. But the key thing is, since you all don't care, I'm just going to sit there and put it in my graph anyway. Are you guys with me on that? So with this one, let's graph it. Make sure you have the 2 that you have on there. And you should literally have a little bit more spread out going this way. You guys just hurt my heart. You didn't think it was cool. Just like, I'm hurt. It's like crushed that no one cares. All right, anyway. And didn't they have the reflection over the line? You guys with me on that? So reflection over the line, way cooler on your calculator. Real cool with the zoom box, but none of you cared until probably the next unit. But fine, okay. Hurt to this day over the fact you will not. Guys, crushed. All right, let's talk about the table for this though. If you're doing the table, you could do use your calculator to your advantage on this one if you want as well. Again, I don't care which one of these you want to put in first, but again, you can strategically pick numbers that work well. And I would probably say do that to your advantage. Like for instance, if I'm going to do f of x first, wouldn't I want it to be numbers that I could easily use? So if you're doing that, here's x, here's my f of x coming in. You could totally use like 2, negative 1, 0, 1, 2. Like, they aren't too bad. The problem is the numbers kind of get weird, but let's try this anyway. So how about the fact we go negative 2 cubed? Well, negative 2 cubed is going to be a negative 8. Divide by 2 is not going to be a negative, is not going to be a negative 4, right? All right, so what if I do negative 1? It's going to be negative 1/2. 0 is going to give me 0. All right, so let's just do one more. Let's just do a positive 2 so we can say we got 4 of them. So we got positive 2, and it's going to end up being at 4 if you plug it in. So I just plugged 2 in, negative 2, 2, all in for x, and we just calculate it. So then if I'm doing it for g of x, make sure you strategically pick what points to use, right? So if I'm going x here, I'm going to come out with my g of x. What points I'm going to pick? I'm going to pick negative 4, right? I'm going to pick negative 1/2, 0, 4. And if I plug them in and they come out to be perfectly matched on the other side, we know they're inverses of each other. So plugging into the cubic root, and this is nice because cubic roots can have negatives. What's 2 times negative 4, my friends? Negative 8. Cubic root of that, negative 2. Same type of scenario going on. If you plug these in, don't they work? Do you see how you can quick, easy? Now someone said, could I use the table function and stuff? Yeah, you totally could. You can even do your calculate trays and like plug numbers in it and it'll show which ones they are, so you can do it that way as well. Graphing calculators are pretty cool. Pretty cool. All right, now, with this one, let's look at 29. And 29, notice, has some limitations. It says x has to be less than or equal to 0. So that limitation got put on our g of x. Why? Once again, because remember when I have the square root of x minus 8 right there, we've got to make sure it only shows half of the parabola. We can't show a whole parabola to work with it. So we have to be very careful with that. But the first process, and most of you are working ahead on this, can I go ahead and just plug it in and make it work? Right? So algebraically, first thing we're going to do. So we're going to go f of g of x. And so when we do this one, so we have the function, we get 8 plus x squared. Here's where you got to be careful plugging it in. So we get negative the square root of the quantity, 8 plus x squared. All right, minus 8. So we get negative the square root. Now notice I get an x squared here. Now, there are some stipulations here. X has to be less than or equal to what? 0. Okay? Because when you look at this, normally when you take the square root of x squared, we automatically think positive only, right? But I'm limiting what my graph is. So guess which one's actually coming out? Not the positive, it's coming out to be the what? The negative. And then that will actually make it a positive x. So this is one reason why I picked to do this one with you, because it was weird and confusing. Don't worry, that's not on your test. Okay? But I just want to show you what you had to consider the parameters. Right? Yes?
Where did you get the negative?
Well, if I take a square root of x squared, what's a negative x times negative x? A positive x squared, right? And so because of the parameter x is less than or equal to 0, I'm not going to use a positive x. I'm going to use what type of x? A negative one that comes out. And so that's where we can come out to make it x. Otherwise, it doesn't come out to be a negative x, and that doesn't work for inverse functions. So that's why I put that one on here, so I'm doing it with you. But again, doing the same type of scenario, we go, the negative square root of x minus 8 goes in for our function g here. So we got here 8 plus, parentheses are going to be huge, the square root of x minus 8 squared. All right, guys, here's where we need to remember our good old math functions. If I square a negative, it becomes out what? Positive. So that negative out in front of our radical sign just became what? Positive. And then you're still squaring the square root. And so that comes out, and that becomes your x minus 8. And it comes out to x. They work out really well. All right. So with this one, good so far? Now, I have a question for you. Let's talk about domains for just a little bit. Is there any domain restriction for my composite function for g of f of x? Do I have any problems where this might not work? can I have negatives underneath my radical? So if I'm plugging it in to g of x, I can't have negatives underneath my radical. So I have a restriction on this one that we need to remember. Remember, x minus 8 has to be greater than or equal to 0 in order for it to even be true. So I get the fact that x has to be greater than or equal to 8 when we're doing this. So we have a restriction on the domain because of the radical on there. So even radicals and all that stuff. So this one's like funky, crazy, not a lot of fun when we're working with it. But let's try graphing it just a little bit. I think this is almost easier to graph without using your graphing calculator real quick. All right, and here's the reason why. Look at f of x. Isn't that just our square root? Right? It flips over which axis? This is at 8. This is our parent function, but it's a negative square root. So what happens? It just goes right. So that's your f of x right there. Now, why do I know where to move? It says minus 8, so I move 8 to the right. Notice I real drawn the scale moment there. But I just moved 8 to the right and reflect over the x-axis, so we know that would be your f of x. Now, the g of x, remember the restriction that was put originally on our g of x. I can't have x has to be less than or equal to what? 0. So when I look at that, that's just 8 plus x squared. Well, we know our parent one, we're up here at, well, make it a little bit better, at 8. And this is our parent function, but what part of it can I use? Just the left part. So this is all that's being graphed of g of x. Now, do they reflect over y equals x then? Yes. So you have to think about even those type of restrictions and how you're working with them, or they won't work. So there was why there was a restriction given on this one. Now again, I'm not giving you one that hard, okay? But let's do C, let's do the last part, let's do the numerical graphs real quick of this. So what do you get here? F of x is equal to the negative square root of x minus 8. And g of x, we're gonna get to equal 8 plus x squared, but we're limited to only use what? X is less than or equal to 0. All right, so friends, let's do this easier. I think it's actually easier to do g of x first on this one. What do you think? Does it really matter? Our table on here. So I'm going to use x, g of x for my table. And remember, x all has to be less than 0 or equal to 0. So I'm going to go keep it easy. 0, negative 1, negative 2. Life goes on. That's where we're going to stop it. Okay? So if I put into g of x, I put a 0 in there. 8 plus 0 is going to be 8. A negative 1. Negative 1 squared is 1. 1 plus 8 is 9. And then you got negative 2 squared, which is a positive 4, plus 8 would be 12. All right, so strategically, when we're doing this, here's my x, here's my f of x. Do that in red here. Of course it wants to do that. All right. What ones am I going to use? 8, 9, and what? 12. And so then you're just going to plug it in. So we get here, 8 minus 8 is 0. The square root of 0 is 0, negative 0. Oh, it's amazing how that works. I put a 9 in there. 9 minus 8 is 1. The square root of 1 is 1, but I'm taking the opposite of that. Negative 1. And if I put 12 in, 12 minus 8 is 4. The square root of 4 is 2. Negative 2. Now, just out of, which 3 methods do you like the best? Of the 3, which one's the easiest for you to do? For most of you, tell me what, yes. You like the table one?
Yeah.
Then you may use it. It's the right way of doing it. Anyone prefer just graphing it?
Oh yeah, that's the best.
Some people are very visual. They're like, just give me the graph. I can see if it reflects over the line. Some people, I'm algebraic with math. Even though I'm a very visual person, I like the algebra part of it. I think it's just that I like solving equations. I really do. I just like simplifying it. But that's my preference. But you just make sure you're able to do it. Are you guys with me on that? All right. So here's what I need for you guys to do right now. put your stuff down here. I'm gonna pull up the Kahoots real quick, but I'd love to make sure you're starting to work on your review sheets. So once you guys start doing that, we're gonna talk about the last couple problems, 8 and 9 together. So everyone grab the review sheet on the way in, and then we'll talk about 8 and 9. I just gotta get it loaded on here as well.